Good afternoon, everyone. Thank you for making it out to my theater session. This is Inception, running Microsoft Azure Stack on Azure. In case you're wondering who I am Ned. Hi, Kenny. I am a director of cloud solutions for a consulting company called AnexNet. I'm also a Microsoft MVP, and you probably won't be shocked to know it's an MVP in Azure Stack. I do some courses for Pluralsight on Terraform and Azure. If you want to talk about either of those things after the session, I'm more than happy to ramble about either of them for a while. I have a blog. The address is down there. It's nedinthecloud.com. Pretty easy to remember, I think. My Twitter's up on there too, Ned1313. Feel free to hit me up there. I also have two podcasts, Anexapod and Buffer Overflow. If you're looking for a fun, informative podcast, Buffer Overflow is probably the way to go. It's a weekly tech news thing. We've been called the morning zoo of tech podcasts, so that's a lot of fun. But let's get to the topic at hand. Before I talk about that, I was told by the Azure product team multiple times to remind you that this solution is not supported by Microsoft. It'll work, but if you reach out for support, it's more of a best effort kind of thing. You know what I'm talking about. Yeah, so it relies on nested virtualization, which ASDK doesn't technically support. So feel free to log issues, reach out, but it's really a best, they'll do their best, but at some point they'll say, okay, it needs to go into physical hardware and reproduce the error kind of thing. So what is Azure Stack and how does it interact with Azure? Hopefully everyone knows what Azure is. If not, there are more than enough sessions to understand what Azure is, so I'm obviously not going to go into that. But there are some occasions, shocking as it is, where you're not going to use Azure. And so Microsoft needed something that you could run on premises, and so their solution is Azure Stack. So the correct way to think about Azure Stack is that it's an extension of Microsoft Azure in your data center, or apparently an SUV that has been ruggedized, because that is also an application, and if you go over there, you can actually see that ruggedized SUV and the Azure Stack inside. Now, the Azure Stack itself is a multi-node system. It is at least 4 nodes. I think it scales up. Have we hit 16 yet? Yeah, we'll go with the, okay. It's either official or official like today that a 16-node system is going to be supported. Previously it was 12, but it's a lot of nodes. It's a lot of hardware. And Azure Stack as a multi-node system is production ready. It's ready for your production workloads. You can only get an Azure Stack multi-node system from an approved OEM vendor. So my good buddies over here from Dell EMC will be more than happy to talk to you about purchasing a multi-node system. Thank you, Kenny. But you can't just take some hardware that you happen to have laying around and turn that into a production-ready Azure Stack. It doesn't quite work that way. It also includes 2 top-of-rack switches in order to integrate with the rest of your network. Because the Azure Stack is going to have a management network, it's also going to have tenant networks that need to integrate. So those top-of-rack switches will either run static routes or BGP to get you connected. The Azure Stack Development Kit is I dropped out for a second. It's a single node unit, and it's for development purposes only. It's like it's in the title. So it's the Azure Stack Development Kit, and it was created so that developers, ISVs, and the people who are curious about Azure Stack would be able to spin up a development version of it and kind of get their toes into the water of Azure Stack a little bit. It's self-deployed, meaning that you can bring your own hardware and deploy it on that. And if my clicker works, the switching for it is internal, so there's no top-of-rack switch to go with that. It has a VM that runs within it that's called the BGP NAT VM, and what that is responsible for is providing that network connectivity that the top-of-rack switches would in a full deployment. Now you might be asking, why would you run this thing in Azure? And that's because the hardware requirements for running the Azure Stack Development Kit are not light. So I don't think a lot of people just happen to have a server laying around that has 12 physical cores, 96 gig of RAM, a 200 gig OS drive, and then 4 more completely separate, you can't just like make it up, 4 more separate physical drives. Those are going to get turned into a storage spaces direct cluster that Azure Stack will use to provision all the VMs. You probably have Server 2016 in a NIC laying around, but the rest of that you probably don't have just sitting on your data center floor for you to experiment around with. And if you do, you probably don't have multiples if you wanted to do multiple deployments. So that's one reason you might do it. The other reason is, for me, I like to run Azure Stack Development Kit workshops, and I don't have 15 of these to provide to the people that attend the session. So what's my recourse? I can use the E16 v3 in Azure to provision this Azure Stack VM. Since Microsoft announced, I think it was last year, that nested virtualization is supported on Azure, now this scenario is actually realistic. I know that Azure Stack is not supported on nested VMs, I just want to say that again, but it will in fact work using that SKU or one of the bigger SKUs. And that is repeating. So the deployment process for Azure Stack Development Kit on physical hardware, you first have to prep the hardware with Server 2016. You don't have to do much to it because you're actually going to boot from a VHDX file. So you download the ASDK files, which are bin files, and those get turned into a cloudbuilder.vhdx file. And then you run an install script, and what that does is it sets the bootable drive to this VHDX file that has all the prerequisites to install Azure Stack. You boot to that VHDX file, and then you run the install script, and that's what actually provisions the whole Azure Stack deployment. That's the physical hardware, so lots of steps there. And then the last step is you wait, because the full deployment of Azure Stack Development Kit can take anywhere from 3 to 8 hours, depending. It's more of a launch it at night, get up in the morning, and it's probably done sort of scenario. On an Azure VM, I have, with the help of others, created an ARM template to deploy the ASDK. So all you have to do is run that template, and then run the install ASDK script, and wait. There's a lot of waiting involved here, probably about 6 hours for the whole thing to get deployed, and then boom, you now have Azure Stack running on an Azure VM. So to run the Azure Stack Development Kit template, I'm going to show you a quick video on doing that. So if you go to my GitHub, it's Ned1313. There's the Azure Stack VM POC repository, and you click on Deploy to Azure. Create a new resource group. Got a few other things to fill out here. The local admin password, the Azure admin password, that's so it can register with Azure for the marketplace. Set the auto config to true and give it a public DNS name, agree, and click on purchase. And that will go through the provisioning process. Now, I do want to caveat this. Right now, the auto deploy doesn't work 100%. It will provision the VM. It will go through the initial installation, but it won't do the full soup to nuts deployment of Azure Stack. I'm still working on that portion of it. I actually had a nice conversation with the gentleman over at the Azure Resource Manager bench to figure out why it's not working the way that I expected it to, but it will deploy properly. So it deploys everything, that's all good. Once you have the VM up, the next thing is there's a post-install script, and that post-install script installs all of the Windows features that are necessary for the Azure Stack Dev Kit to work. So things like Hyper-V, it needs the Active Directory management plugins, and a number of other roles need to be installed. Then it will download the ASDK files for you, and out of that ASDK file, it'll create that VHDX file, and rather than setting it as the bootable drive, which doesn't really work in Azure, it opens up that VHDX file and pulls out the directories that have the prerequisites on them and drops them in the C drive. And then it has to apply a couple workarounds, the first of which, it has to go into the PowerShell functions and look for the one that checks to see if you're running on a virtualized platform, and remove that, because otherwise the script will kick out, you're running on a nested virtualization, that's not supported, sorry, game over. So we remove that, and there's a couple other workarounds that get applied there. And then it installs a companion service. And what that companion service does is when you install the SDK, that one VM that's doing the switching and networking for you, that BGP NAT VM, that's expecting to have a virtual switch that has NAT capabilities so that it can direct traffic appropriately. That switch doesn't exist because we didn't use the VHDX file to boot from, so that companion service waits until that VM is created, and once that VM is live, it creates a new virtual switch, removes the network adapter from the default switch and attaches it to the new switch, so now it can do its NATing appropriately, and then the companion service turns itself off. So what does the actual install of the ASDK look like? This is super exciting. So once the VM is provisioned using that template, the first time you log in, this is what you're going to see. There'll be a nice little shortcut to install the ASDK. So all you have to do is right-click on it and say Run with PowerShell. And then it's going to prompt you for a few things. What's the password for the administrator? It's going to ask you what is the Azure AD user. Enter all that information. And then it's going to confirm what version of ASDK you're installing and go off to the races downloading those bin files and creating the VHDX. This process will take probably about 6 hours, to be honest. This is not an extremely fast process, but if we fast forward in time, when it will reboot once, and then you can log in again using the Azure Stack Administrator, and when you log in and it's finished, it'll say, action deployment is complete, and that's how you know that your Azure Stack is up and running. Now the question that you might be wondering to yourself is, how much does this cost? Because you know that it's not going to be cheap. So the answer is it's not free. You are running in Azure, you can't run on a free tier for this size VM. So if you wanted to go premium, you wanted to go all out, you could provision this as an E32 with 32 cores, 256 gig of RAM, 5 256 premium SSDs, and that's going to run you about $1,500 a month to run. Not cheap. There is the option to run on what I would call standard specs, so the E16, and then the nice thing is standard SSDs are at least in preview in all regions now, so the template that I use defaults to using standard SSDs instead of premium. So if you use the smaller specs and use the standard SSDs, it might not install as quickly, but it's only going to run you about $855 to run a month. But you might say to yourself, well, I don't want to have it running all the time. That doesn't make sense. This is Azure. I shut it down when I'm not using it. Absolutely. So how do you shut down the Azure Stack Development Kit on Azure? Well, first you log in and you start up a administrator PowerShell, and you get credentials for the Azure Stack admin, and then you're going to enter a PowerShell session to a special VM that exists on Azure Stack. It's the protected endpoint VM named ERCS01, and that's where you can run protected commands from. And I'm going to run stop Azure Stack, and what that does is gracefully shut down the 15 or so VMs that make up Azure Stack. Did I mention it's about 15 VMs? That's why you need such a beefy machine to run this thing. That whole process, if you look at the start time and the end time, takes about 30 minutes to run. So shutting it down is not just pressing a button and you're done. You run this, you wait 30 minutes. When it says everything is good, you can go back into the Azure portal and deallocate the machine. The startup process is much, much simpler. You turn it on, and then you wait probably about 30 minutes to an hour for it to start up those VMs in the correct sequence for everything to function properly. You can speed up that process a little bit by going into the cluster failover manager and manually starting the VMs, but if you don't start them in the right order, in the right sequence, things might not go, things probably won't work well. So I don't recommend doing that. Just be a little patient. There's a lot of waiting involved with Azure Stack at times. Not the production one, but Azure Stack Development Kit, there's a little bit of waiting involved. Once you've deployed Azure Stack, by itself, there's not a whole lot of stuff on it from a tenant perspective. It creates the default subscription, and you can log into that and associate it with the marketplace, and that's probably one of the coolest things about Azure Stack is that you can syndicate the marketplace in Azure Stack with the Azure Marketplace, meaning that offerings that are approved to be deployed on Azure Stack are available, So if you want, the latest Server 2016 or the latest SQL Server 2017 or even Server 2019 when it comes out, you don't have to build the image yourself. You go to the marketplace, you add it from the marketplace to your Azure Stack, it downloads the file, and then you can present it to tenants for deployment. That's pretty useful, and I think that's probably my favorite thing about Azure Stack is this marketplace integration. But that is not set up by default by the initial scripts. Also, Azure Stack has resource providers that allow you to use MySQL as a service, SQL as a service, and the Azure App Service. None of that is configured out of the box either. So there is a script called the config ASDK script, which is maintained by someone who's actually sitting in the audience. I can see him right here. Hi, Matt. It's a little broken, by the way. We can talk about that later. So all you have to do is, I use the hash table method in PowerShell. So you can define all the parameters that your PowerShell function takes in a hash table, and then run the script and pass it the parameters as a hash table. It's easier to read and easier to do. So fill out the parameters with all the necessary information. It does look for an ISO for Server 2016. The updated version of my template automatically downloads the Server 2016 ISO and puts it in the same folder as the config ASDK, so you don't have to go searching for that. But yeah, you basically highlight that, run it, and then run the config ASDK script. And this one, if you leave it with just those arguments, will register it with the marketplace. It will make a bunch of tweaks on the virtual machine for it to run better and also not lock you out after 90 days or 60 days for the admin password. And it will provision all of those resource providers if it wasn't a little bit broken at the moment. So there was some updates with 1808 and the versions of PowerShell. You're nodding your head, you know exactly what I'm talking about. And so for whatever's going on there, PowerShell barfs on this at some point. So we'll get that fixed, don't worry. It's fixed now? Oh, your script, he fixed it. I have to fix it now. It didn't work for my demo last night, but believe you me, once it's updated, it will work properly. So if you want to go ahead and do this yourself, you're more than welcome to. If you go to my GitHub, it's ned1313, Azure Stack VM-POC is the link. Go ahead there, you can deploy it straight from there, or you can fork it and mess around with it on your own. You can always hit me up on Twitter at ned1313 if you're running into issues, you have questions, or you can log issues on GitHub. That probably makes a little more sense. You can check out my website, nedinthecloud.com. I've been blogging about Terraform for the last 60 days, so I'm ready to switch back to Azure Stack for a little bit. I'm a little burned out on that one. I do want to shout out to a few people that helped contribute to making this whole thing work. The first is Matt McSpirit, who is here, so thank you, sir, for helping work that out. Yagmir Sahin, I think that's how you say his name, developed the template in parallel with me developing my own template for deploying this thing, and we ended up borrowing some of each other's scripts. So he also has one that will deploy Azure Stack on Azure. And last year, Andrew Westgarth, who's responsible for the app service, helped me figure out how to automatically deploy the app service on Azure Stack instead of the manual process. So big shout out to them. If you enjoyed my session, please go on the app, rate me, be as brutal as you want. I can take it, I'm a big boy. And that's it. Thank you, everybody. Enjoy the rest of Ignite.